the SQL queries. And we're going to cover them today, just the simple part of it. And then we will go into a more advanced part of it next module. So when we talk about SQL language, so who can remind us what the SQL stands for? Structured Query Language. So SQL stands for Structured Query Language. So SQL language has two primary aspects to it. We have data definition, where we call it data definition language, and we have the other aspect is data manipulation aspect. So when we talk about the data definition, from its name, we define the database objects. So who can remind us what we mean by objects in a database? So a table can be an object. An attribute or a field in a table can be an object. An index can be an object, just to name a few. So data definition language will define which of those are going to be created. Basically, it will create them, alter them, or delete them. So it deals only with the high-level objects. And then when we talk about data manipulation language, it deals with the data in those, with the data elements only. So we are not talking about objects. We are talking about the cell values when we talk about data manipulation language. So let's look at some of the examples that we do in a data manipulation language. There are 4 operations, you can say, that are dealt in the data manipulation language. One is data retrieval. So remember, we are dealing with exact data. So we retrieve data using data manipulation language. We also update data or a record using data manipulation language. We insert new records into that table or object using data manipulation language. And we delete those records or data elements using data manipulation language. So when we say data retrieval, some people might also call this or put it under not data manipulation or not under data, they would put it under data querying language instead of data manipulation language. Because you remember when we say there are 4 aspects to data manipulation language? So retrieval, update, delete, and retrieve, insert, and insertion. So those are the 4 aspects. Just to rename them, data manipulation aspect or operations, retrieval, insertion, update, and delete of data elements. So the definition, what is the definition of SQL? It's a standard relational database language that incorporates those 2 languages, the data definition and data manipulation language. So when we say it is a standard, what do we mean by that? So far we have been dealing with some standard terminologies that you have applied in your database. What do we mean by standards? So if you go to McDonald's, they say they have a standardized model all over the world. So when you go to McDonald's, anywhere in the world, you will see it structured the same way. So what do we mean by standard? It looks the same. It looks the same, and it is the same wherever you go, you will find it the same. So when we say a standard, especially for SQL, it is a standard. If you use SQL here in the United States or in France or in Germany or in Russia, it's going to be the same SQL language. However, some vendors have some modifications to it. For example, if you work for Cerner, some of you would work for Cerner, you will notice that some of the SQL that they use, it is customized or it is just for their own, but they are using the same big picture that we are going to cover here. So they have maybe specific key terms for their own. That way, that makes it much difficult for attackers to understand the structure of the data. So they would use some of those differences. And you will notice also that we will have some differences between Microsoft Access and Microsoft SQL Server SQL commands. There are just tiny differences, but the big picture is the same. When we talk about the keywords, they are the same. When we talk about the structure, it is the same of the SQL command. So what are the basic features of standard SQL? Yeah, we have data definition language, where in this data definition language, we can create tables. Basically, instead of creating tables through design view, you can actually write the code to create the tables yourself. And we will do an example today. So we will create a simple table just with the commands, with writing SQL command or sentence. So it is used for data manipulation, so we can update, delete the data elements. And there are command operators in the SQL. So what do we mean by operators? We have two types of operators. We have mathematical, or we can call it logical. So mathematical as well as logical. So we have two types of operators, and we will cover them in a little bit. So arithmetic, comparison, logical operators, those are the three that we can, that are available for us, and we will cover them in a little bit. And there are some functions also. SQL is used for functions as well as for transactions. So what are some of the functions that we have been dealing with so far? Calculating the average, calculating the sum. That's a type of a function, isn't it? So, and we will talk about it in a little bit. And transactions and procedures. So there are two basic options for executing SQL commands. You can either use the interactive SQL or the embedded SQL. So from its name, when we say interactive, so what would you say is interactive? Something you have an input, you have to put an input in, and you will get an output. So something that you have to pitch in something, you have to contribute with. So when we say interactive SQL, that means an end user will have to put the command, will have to directly interact with the system, with the database. So interactive means the end user directly interacts with the database system. So when we say embedded SQL, embedded from its name, that it's not direct. It can be embedded in a programming code or in an application procedure code behind the scenes, so we don't see it. So for example, if you go to Walmart and buy a product, so you will just slide your card, and then there are some SQL commands within the application that Walmart uses that will get the money from your account and put it into Walmart's account. So that's an embedded SQL command. So you don't necessarily put or enter that SQL command yourself as an end user, but it is already embedded within the procedure. So now we are clear what we mean by embedded versus interactive SQL. And within the interactive SQL, there are two types that you can use interactive SQL. There is the command prompt, and there is the text-based interfaces, as well as actually three, I would say. So the command prompt, and there is the text-based or character-based interfaces, as well as the GUI, graphical user interface, GUI. But the GUI is not very common What we are using in Access is the only GUI that we can kind of see. But other, like SQL, will have both. Will have the command prompt, which is the black screen, and then you put some. How many of you have dealt with that black screen? So that we call it command prompt. And then we have the text-based interface where you will enter also command in a similar fashion, but it is more of much clearer than and easier to use than uh, the command prompt. But both of them you have to enter the text. So there are some advantages and disadvantages of using the text-based interfaces. So what we mean here by text, so this is the command prompt. This is how it looks like. It's not friendly to use, and it doesn't look like fun to be working with this. But this one is a little bit acceptable, as you can see it. So this is what we call it here, the text-based interface. So what are the advantages? There are some advantages and disadvantages of using the text-based interface. So what is the disadvantage of it? It is complex. Text-based, it is complex. It's not like that. The query by example that we did in Access, where you just drag and drop, and then you just put some command, and then it populates it for us, the query. But this text-based, you have to enter keywords, you have to put parameters, you have to put the conditions where you want the retrieval or the creation to be or update to be. So what is the advantage of using the text-based interface is it is complex. What do we mean by complex here? So when we say complex, that means if there is an error message, the feedback that you will get from the system is so vague that you will not be able to fix it easily. And it is made that way on purpose. So it is made that way on purpose. If you try to enter a command, a SQL command, into the text-based interface, and you miss the comma, you misspell the field name or the table name, you will get a vague kind of feedback pop-up message. And it is made on purpose. Who can tell me why you think that it is vague? The feedback would be vague. Yes?
Having security reasons?
Excellent. Perfect. Exactly. It is for security purposes. Because if it is so easy, it explains to you why your command did not go through. That will make it much easier for attackers to understand the architecture of your database. What do you mean by the architecture here is a logical model. So if they understand the logical model and the connection between those tables, they will be easily able to manipulate and attack your system. So for security reasons, it has to be complex. But what is the advantage of using text-based interfaces? The advantage of that is you can use batch files. So basically you can just copy those batch files and drop them into this text-based interface and run. So it will populate or create hundreds of tables for you in a split of a click. So that's the advantage of it, is the batch files. So embedded SQL, we already talked about it. We said it is embedded mostly within the applications and procedures within the applications programs. So what is the anatomy or the structure or the syntax of an SQL command. This is what it is. So this is exactly what it is. So it includes command name. So you have to have a command name. This command name can be select, it can be alter, it can be delete, it can be update, and it can be even drop. And we will look at each one of those command names. And then there are also keywords that are needed to be used within the SQL command or statement. So the keywords, when you select, you will have to have keywords such as from. So we will have to select, for example, certain fields that will be, the fields will be our parameters. So when we say select, then we will have to identify the parameter, which will be the fields that we want to select. And then from is a keyword in that statement. And then we need to specify another parameter, which will be the table name. Select, for example, all from the TBL patient. And then there is another keyword also we can use is where. So those are kind of an examples of the keyword that we would use in a SQL statement. And the parameters can be the field names, for example, in a table. So what do we mean here by command keywords? They describe specific actions, and command parameters can be like the fields that we have to specify. So look at this example. This kind of example here tells us exactly how the SQL command should or is structured. So especially if we are dealing with select. So select, that means we need to retrieve. So we will select, and then we need to specify the field names from that particular table, and then we will have to use a from in order to tell the system to pull out those fields from a specific table that we need to give it a name here. And then if we need to give it more specifications, we can use the where keyword and then specify exactly what criteria we need to pull out for that particular command. So what do we call this qualifying condition? We call it the search IQ. So this is the search IQ. And we call this the parameter, keyword, and so on. So if you are using an SQL server, then you will have to have a connection. It means a username and login. So you will have to have a connection to the main SQL server. And the results might vary according to the command, if you are using select or and so on. And so let's look at some of the examples that we will get into in a little bit, and I want all of you to participate. So when we say select, which is the command name, is a declarative statement or command word rather than procedural. So what do we mean by declarative here? Declarative here means it doesn't give the exact steps for the system to follow in order to retrieve that data. And then the database management system for us, it analyzes the SQL statement that we put and then creates access path for us. If we are using SQL Server, you will see actually a map of the sequences from where the data was retrieved. And this is an example of a data retrieval. So this one gives you some examples from the book. But let's get into Blackboard and download, or if you already have the clinic file with you, that would be great. So let's pull that out, please, and we will run some SQL commands using the clinic file. If you don't have it, I already have it here for you. Under Module 6, it's the clinic access file. So let's do that. We already have it here. So now let's learn how to use SQL using Access and to use text-based interface. So for that, what we will do, so let all of us do this. So we will go to Create, because part of the assignment is to do it this way. So Create, and then let's say Query Design, and then we'll close this guy. We don't want it. And then in the bottom here, or in the top here where it says SQL View, you can click on this one. Either SQL View, or there is in the bottom left right corner here, it says SQL. So either way, it will take you to this screen. So this is what everyone got it. So if you didn't, let me know. Everyone? Okay. So now, instead of going through design view and so on, pull out everything, can we create a simple command where we are going to create to retrieve all the items that we have in the patient table? So we'll say select the asterisk or the star sign means all. So you might hear me saying select all. So when I say all, I mean the star sign. The star sign in Access means all. So select, oh, you want me to magnify? Sure. All right, can you all see? So select all. And then, so what did we say the command word will be? Select here. And there are some keywords that we are going to need to use that are very common we talked about. So we say from and where. Those are keywords that we will need to use to be specific exactly where what we need to retrieve. So let's say that we will use the most or the minimal keywords that we need is select and then name the parameters, which in this case we are naming all the parameters in the fields in a table, and from. So from is the minimal requirement keyword. So if you didn't use where, it should not be a problem yet. So it is not necessary, but if you need to kind of pinpoint certain data, you will need to use the where, specify the exact one. So let's say select all. What is the keyword now I need to use? Because select all what? Is that right? I need to specify from. So select all fields. That's exactly what it treats so far. From. So it is not case sensitive. So feel free that if you are not putting the upper lower case. So select all from. What table do we need to select? Just pick a table from the ones that we have so far here. Patient. So but we need to be specific here. If we want to create and not get any errors, we need to be able to spell correctly the name of the table and the name of the fields, exactly how it is in the design view. So select all from TBL, patient, And then we need to make sure that we end this statement with a semicolon. So now, if you run this guy, boom, you see? If you want to go back, then we'll just go back to SQL at the bottom. So this is what it did. It's very simple, tiny command pulled out for me that whole query. So that was kind of general, wasn't it? It was general. But can we go a little bit more specific, you think? Yeah, we can. But let's continue and then we will get a little bit more specific. So there are also SQL can be used for expressions. So there are some explicit and implicit expressions. So what do we mean by implicit versus explicit expressions in SQL command? So implicit means that when we say 5 plus 1 will give us directly what is going to give us. 5 plus 5 will give us 10. That's implicit, so we already know it. But if it is explicit, if we are calculating it as characters or as strings, so if we are calculating or adding 5 as a text plus 5 as a text will give us what? If we are calculating or adding 5 as a text plus 5 as a text will give us 55, because we are basically concatenating. Okay? So the implicit is the exact mathematical results, and the explicit is when we want to do some conversions. We want to convert those, for example, strings into commands. So now let's look at trick. Not a trick, but this is a fact that is a feature that is available in Access. So now let's delete that command that we just put. Now we can use this SQL command as a calculator. So let's see here, we will say select. So this is our command keyword. And then what calculation do we want to add? Let's say we want to add some numbers. Let's say 25 plus 25. So I'll just put 25 plus 25. Do you think it will run here? No, it will not. What do I need? Semicolon. Perfect. So let's run it. You will see now. You see what I got? Isn't that cool? So you can do multiplications, addition, subtractions, whatever you want. It will run it for you. So that was one thing. Another thing that I wanted to show you as well was, let's say that I want to add 5 as a text as well as 5 as a text. So if it is a text, that means we need to have quotation marks. So let's put only 5. So I'll put 5 and plus 5. So this is what I will do, and then I will run. So now what do you get?
So you need a semicolon for this?
Yes, you will definitely have to have everything. Any command, we need to use a semicolon. So, but did you see now what we mean here? Because if it is a text, it is left. But if it was numeric, it would be right aligned. So this is what we mean here by implicit versus explicit. So when we are adding those two numbers as text, that means it is explicit. If we are adding them as numbers, implicit. And now let's look at the SQL operators. So we have SQL operators that can be arithmetic operators versus logical operators. What are some of the examples of arithmetic operators? So who can give me an example of arithmetic operators that we can use in SQL commands?
What's that?
The plus sign. What else? Multiplication, division, subtractions. So we got the idea. So the arithmetic operators are those, the equal sign also, isn't it? Or not? But at least we got the idea, arithmetic. So those are the arithmetic operators. And then we have the logical operators. So logical operators, who can give me some examples? So let's get a little bit deeper. What do we usually use in if statements as logical operators? Yes, greater or less than, equal, not equal, like, not. So are some of those we have already covered. So not equal or equal, not or like, and so on. So there is unary operator. What do we mean by unary operator? From its name, it means one. When we have only one operator and one operand. An example of that is not. So we have only one operand. And then binary operator, where we have one operand, but we have, or one operator, but we have two operands. So we have like or, so this condition has to be met, or this condition has to be met. So we have one operand here, one operand here. Those are the unary operators. I mean binary operators, because from its name, bi means two. Yeah. So these are some of the examples that we can see for arithmetic operators: plus, negative, or subtraction, multiplication, division, and percentage. So we have done this. What about the comparison operators or logical operators? Would this be some of it? Can we call these logical operators or comparison operators? Not equal, equal, and so on. So we covered this in Access, but I would recommend that you pay attention to those, because this will help you a lot when you do the assignment and for the exam as well. So it shows you what symbol to use when. Although they are common sense that you have been doing since elementary school, but you will be using them in SQL. So the logical operators are here. Basically, they are words that we use, such as and, between, like, not, and or. So let's see here if we can use something to apply these logical operators. So let's say that I want to select all from table patient, but I want to specify exactly what I want. So I want to select all from patient table where the date of birth or birth date is greater or equal to 1/1/1980. So I want to select those millennials. Have you heard about millennials? So we want to select those millennials in our database that were born after January 1st, 1981, and those people who have parents in our database. Remember when we did the parents is not null? So let's do that. Can you do it? Can you try? Give it a shot, and then I will pass by and see how we can do that. So let's run that command. So select all from patient, and for those patients whose birth date is greater than 1/1/1980. So let's start with that one. So just for those patients whose birth date is greater than 1980, 1/1/1980. So the first, yes. So the first thing I would do is to, as I mentioned, I need to understand the exact spelling of the field that I'm looking for. Here I'm looking at the birth date or date of birth, how you spell in the patient table. So I will go to the patient table. And I go to design view to see how they spelled it. There it is, birth date. So that will make my life much easier now. Birth date. I'll just copy him. Close this guy. And go back to my, greater 1980. So 1/1/1980. So what would you put? What would you put, Melissa? That what would be the
Very strange.
Now we have a now I'm listening there.
you have to use the dates, they have to be surrounded by number sign. Hashtag.
So that's where I just went to. Yeah. Like it came up, but I touched the other thing. Yeah, I would like I would be in that first this. Yeah, it would because it has brackets.
But it could be easier, like, but if you find that
I was supposed to put like, I was gonna like brackets. I was supposed
that
to
we
put
don't
the date, and then yeah, that's what I'm doing right here, so I can actually put it later. What if I do it?
That's right.
maybe you could for 80, but you have to put hashtags before and after the date to do the exact. It won't work if you did, yeah. So if you put the hashtag, it should work. Where? Date of birth, patient.
Where comes the order? That birthday.
Now, so I can take it out.
Yes. I don't know. Oh. That's from where birthday yeah, I was guessing. I was like, what's either yes or no, so I figured I but for the first part, it's gonna be.
Everyone got it?
Yes, not all. And then like once, and then two. Yeah. It's okay. What? Like all from.
So now let's add a little tweak to it. So now we have been able, we were able to select all those million, whatever the year is. So we were able to get those people whose age or date of birth is greater than 1/1/1981 or 80 or whatever number you put. That's fine. So now let's add one restriction to it, one constraint. So now we need to add a logical operator, which is AND. So we want them to be their date greater than 81, and they have their parents is listed in the patient table. So if you look at the patient table, did you see here some of the patients or some of the patients' parents' names are listed here? Is that right? Do you see? Some of them they don't. But we want only to the query to retrieve for us those patients whose parents are here in this database. So now we understand what we really want, but you might not be able, we are not clear how to get it. Is that right? But at least, do we know now what we really want to get? Please we understand the question. So now let's do that. We already have the first part done. Now all we will need to do is to add and before the semicolon, and then put a parameter to specify what we want. And parent, which is the name of that field, not null.
Not what?
Not null.
That's one word.
N-U-L, no, that's separate words. So let's see if that would work. Did it work for any one of you so far? So let's see. But you need to close this guy. So select all. So parent is not null. So let me put the is. Is not null. So select all from TBL, patient, where, birth date. Did you get it? Okay, great. All of you? Is not null. I'm pairing? Nice. So that's, yeah. So I'm pairing. If it exists, yes. But it will be easier, it will be nice to have that. Yeah. Not knowing much specific that it guarantees to us that we will be. I mean, if anything that is so valuable, we want to get those that have value. So not all. I know it might work without specifying not null, but we have to put it just to make sure that, because sometimes we might deal with, life and death. People who don't want to live it, or some people's financial. So everyone got it? All of you? So all of us are good? Okay, great. And then we have also learned that we can use some of those characters here, the like operators. So if you are using the SQL server, which we will be using it with the web query. So we have a web query that we will be using for the assignment. So you can use the percentage sign in SQL Server, which also is used as question mark in Access. You can use the underscore, which means that is one character. So for example, we say select all from patient table where last name starts with underscore O, and then asterisk. So it will select Muqbel definitely, because underscore will stand for any character that is M, A, B, C, whatever number, whatever character it is, underscore. So underscore is kind of what we call a placeholder for a character when we use the underscore. And then bracket, we can put anything in that bracket to match the keyword that we want. We have done this in Access, don't we? Yes, sir.
I just had a question. If you were going to search for a last name starting with O, would you have to have quotation marks around just the O?
Yes, so you will have, let's say that we want to select, so select all from patient where last name, like, quotation mark, O, and then star. Quotation mark. Let's do that. Can you do it? Let's do that. That's a good option. So let's select all from the patient table where last name starts with O. Select all. You all got it? Did it work for you?
Maybe it's after the.
Can you see it now? So we have the asterisk, means whatever character is afterwards, you don't get. Just give us something that starts with an O. Okay? So when I run it, do we actually have any names that start? We have only one, isn't it? Then, so let's see. Did you all get this one? So select all from asterisk. Select all from TBL patient where last name like quotation mark O. Did you all put this or something?
So, yeah, I did.
Okay, so
No, so it's.
So make sure you didn't have space between the quotation mark and O. So this is not easy. Asterisk
I thought you were also doing.
Anyone still have it? Did not work for you? Anyone? Did it work for everyone? Okay, great. And then there are some functions we can use SQL for. There are deterministic functions where you can, for example, you will get the same value or output no matter what it is, so it's not variable. And you have non-deterministic functions where it will vary. For example, to get the date or the time, it varies. Every day you have a different date. Every single second you have a different time, and so on. So that's what we mean by non-deterministic functions. We have numeric functions, calculating the average, standard deviation, and so on, examples, and mathematical ones, sine, cosine, date, and aggregate, which is the sum, count, and so on that we have dealt with, and strings, converting. There is also some feature in Access where you can convert some letters, whatever letter that the end user would enter, you can convert it to capital. And if you remember in one of the modules, it shows you how to do that. To capitalize every letter that an end user will enter. So we have concatenation of strings that we have learned to do. That was a function that we did through builder and conversion. And now let's look at the data manipulation commands. So what do we mean by data manipulation commands here? Remember when we talked about it earlier today? Means we can manipulate or we can do 4 things with the data, not with the objects. Is that right? What are those 4 things? Can you remind us? Yes. So let's do each one of those guys here. How about those 3? We will do one insert, one update, and one delete. All right? Using Access. So let's open our file. So what we want to do here, for insert, we want to insert into the table invoice item. So the table invoice item, we want to insert the following data, because in the invoice item we have only two fields. So in the first field we want to insert a new invoice item ID, and we want to call this new invoice item ID DG888, and we want to put the invoice item wrap and lap, or whatever name that you want. So let's do that. So we need to insert that here using a command, SQL command. So let's close this guy. But before we do that, we need to go to design view to make sure that we understand and we know the exact spelling of the columns in design view. So this is how they are spelled. All right, so now we want to insert. So what is our command keyword here? Insert. So let's start with insert. So insert, and then the syntax will be different from select here. So insert, we need to specify, tell it what that table is. So insert into, and then what is the name of the table? We want to TBL, the name of the table? TBL invoice item. All right. So insert into invoice item, and then I will need to open parentheses, and I will enter the name of the two fields that I have. So what are the name of the first field for invoice item? Was it invoice item ID? Wasn't it? So invoice, no parentheses. So remember the first parentheses, we will not put quotation marks around the name of the field. So invoice item ID, and then comma, space, the name of the next field. What is it? Invoice item. Was that right? Invoice item. If we are not sure, we can always go back. See? You can even copy and paste it. If we are not sure, that way we don't make mistakes. So now we told it insert into the invoice item table, and then we specify the name of the columns, and then we need to specify the keyword here will be value, and then open.
You show the example.
There we go. So value, and then I will open parentheses, and here I will put the exact data that I want to insert. So what did we say we want to insert? Usually. So in this case here, what is the data type that I want to enter into that field? The data type will be text, because we don't want, it's not numeric. So if it is text, then I have to use the quotation mark around it. So quotation mark, and then DJ888, then close that quotation mark, and then comma, and then open new quotation marks, and then start whatever that name of this item. What do you want to call it? Vertical usually has good names. Just give us a name.
Brownies.
Huh?
Brownies.
Brownies. Brownies. So let's close that and make sure that we have semicolon at the end. And then say run. So value. So now it is catching value. The value keyword, it has to be values with an S. So let's put that one. So it is very sensitive, and that's why we said it is complex, because if you have a mistake, it doesn't tell you exactly what happened. So let's run it. Could not find output table, TBL, and voice because they misspelled it. Did you know this? I called it invoice. So invoice, and then run. It's already open. So now it wants me to close this guy. So it will keep until everything is perfect. So run. Invoice item ID. So invoice again. So now let's run again. Yay. It was. So now it is asking us that do we want it to append this one row or not? Yeah, we want it. Yes. So now if we open that table, you will notice that we have that brown guy. You see it? Yes. You all got it?
Yeah.
So now we got that one. How about now, can we update that? Brownie, oh, that was a mistake. Maybe brownie is not, it's not a diagnosis, isn't
Yes,
it?
it is.
So let's correct that one. Let's update it. To do that, we will need to create a new syntax here. So we will say update. So in this case here, so we will start with the keyword command word will be update. And then we need to specify the table that we want to update. So TBL, invoice, TBL, invoice, item, is that what we called it? And then we want to specify and then we want to set, so update, invoice item, set. What was the name of that field? What's the name of the column that where the brownie was in? Invoice item. So let's put it here. Invoice item equal, what did we call it? Brownie? Brownies. So what do we want to put it here? We don't want it brownies because it was already brownies. So what do we want it to say? All right, let's put it cheese. So we want to change the brownie to cheese. So where invoice item equals brownies, and then close this guy. So now what we are telling it, we are asking it to update that field where we put it brownie to change it to cheese. So let's do that. So you should all get this one where it says you are about to update one row. So yes. And then we will go to invoice item. Yay, we got the cheese. So now we got the idea. How about we know that there is no cheese and there is no brownies? We just want to delete this one. Let's delete it. How about that? So in order to delete, we need to use the command word where it says delete. So delete from TBL invoice item. So we need to specify the table and then specify the column invoice item equals, do you want invoice item or invoice item ID? Let's do ID, how about that? Invoice item ID, this is easy to remember, equals TG888. And now let's run it. We're about to delete one row. Yes, we want to delete them. Now we don't see them. So that's good. Now we got the idea how to do the data manipulation. So far what we have been doing with the create, update, and delete, we have been manipulating data, the values inside the tables. What if we want to create a table by itself? So what would be the name of that language? But the name of the language. So far we have talked about two types of languages, DDL, data definition language, and data manipulation language. So we said in the data definition language, what do? We create objects. So we create tables, create fields using the what? Data definition language. When we use the data manipulation language, we use that to create, delete, update, or manipulate in general the data itself. So in this case now, let's move on to create a table with its specific fields. So we'll create objects using data definition language with SQL. So let's say that I want to create a table. I will call it TBL test. And I want it to consist of last name and first name only. Okay? So let's do that. We'll create a new table. We will call it TBL test. And we want the first column to be last name. And we want to specify the number of characters to be 20, the size. And then the second column, we want it to be first name. And the size of that, we want it to be, let's say, 20. Can we do that? Yes, let's do that. So now we will just say create. So because this is the syntax for it. So you will create table and create index. You can alter, means modify or update, and you can also drop. So the command keys here for data definition language is a little bit different from data manipulation language. If we want to delete a table, we can say drop that table. We don't say delete. If you say delete and you give the name of a table, it will delete the content of that table, but not the whole table. So let's do that.
Should we call it something else? Like table test or exists?
Okay, let's call it something else. Exam, how about that? Or no, we don't. Okay, let's put it exam. So create table. So we need to put that keyword, create table, and then TBL exam, and then open parentheses, and then say last name. Now we need to specify the data type. In this case, we will call it variable character, var. So variable character. So var, which is variable, var, which is for character. So the first words from var, and then, can you all see it? So var, and then open parentheses for the size. What is the size we said we want it to be? 20. And then comma. Now we need to start the new column, the new field that we want. What did we say we want it to be? First name. Again, var 20. And then close that parentheses and put this our semicolon and see. So we didn't see any feedback, did we? Did you all see when you run? We didn't see anything. It went so fast because it's already there now. So if you go to the table section, you will see that the table is already there. So now did you see? Table exam. So did it work for all of you? It worked? So now what if we want to, if we are interested in adding or updating this table, and we want to add, let's say, a date field, we can do that as well. And but we will need to use the alter keyword, command keyword. Now let's say we want to drop this guy, want to delete him. How about that? So now what we will need to do to drop him is just type drop and then table. What is the name of this table that we just created? TBL exam, semicolon. And then you can run it, and then it will do the magic for us. So you deleted it without giving us any feedback, but it did. So that was all for today. Do you have any questions? If you want to start working on your in the assignment, we have, let me just show you really quickly here, that we have a web query. So it is in Blackboard. So there is a link here called web query. Here, this web query, I will just give you a quick demo. You have actually the actual access file. It's called pet store. And you have all the structure, all the tables, you can see them in that access database, which is this guy, Sally's pet store. So those are all the tables that we have here. So, and here, for example, if I want to select all from animal, in this case, in SQL Server, you don't have to have a semicolon. Just run the query, and you will see everything here. So I will let you play with this website using the pet store access table and see what you will get. All right? Yes.
So is that web query site already linked to the pet database, or do we have to open it simultaneously?
No, it's it is separate, but it has the same content.
Okay.
So we created it here for us, but you know the content should be the same. Yeah. All right, and I will see you on Thursday.